Hello, everyone. How y'all doing today? We're going to now progress onwards in our discussion. We look now at bacteria. So up to this point, you should be very knowledgeable on the themes of the course. So ecology, evolution, taxonomy. We've covered then viruses. So you know about these non-living parasitic entities that infect cells, causing either lytic cellular destruction or lysogenic sort of integration. And we said that viruses are like the transition from the non-living world to the actual biological, biotic sort of aspect of life, right? So we're going to look now onwards at diversity of life. So we're in a level more complex than the viruses. So this is actually now living, like 100% living organisms. There's going to be a total of 6 taxonomical kingdoms: fungi, plants, animals, protists, eubacteria, and archaebacteria. Right? So we're going to kind of progress through the rest of the semester looking at these 6 different taxonomical categories, right? And what makes them different? What similarities do they share? And if you notice, they're all somewhat linked, right? They all have some sort of connection. And that connection then sort of originating at some point back in the history of Earth. This is where we think then that transition would have been sort of the chemistry world, viruses somewhere here, and then be through the process of evolution, through whatever you sort of have the idea of how life began. We know we transitioned from a non-living world to a living system, right? And the first living organisms on planet Earth were some sort of prokaryotic cell, some sort of prokaryotic life. So we're going to look at 2 types of bacteria, right? The ancient or archaic bacteria, archaebacteria, and the true bacteria. So they're both bacteria. They're going to have a lot of similarities, but they're phylogenetically different enough to categorize them into 2 separate distinctions on this tree of life here. Yeah. So I'm going to kind of go out of sequence. So normally we start with the archaebacteria and progress to eubacteria. I'm going to start with this sort of little dead-end branch. I'm going to start with the eubacterians, give you the information and knowledge on that group, and then we'll look at the archaebacteria. But in reality, it's sort of thought that the archaebacteria came before the eubacteria. But again, I'm going to do them out of sequence here. So when we talk about bacteria, we're talking about prokaryotic cells. And I hope you remember this from 1306. Prokaryotic cells being simple, lacking organelles, being protected by a cell wall. And the book uses the term ubiquitous, right, to describe the abundance of prokaryotic cells. So ubiquitous. Ubiquitous translates to found everywhere, right? If you were to analyze maybe the chair that you're sitting on right now, if you're to analyze the laptop keyboard that you're typing on right now, your skin, our mouth, the air that we're breathing, right? If we analyze and really look for, we will be able to find at least some species of bacteria. They're everywhere, in all habitats, in deserts, in forests, in sort of tropical, in underwater environments, in cold and hot, right? So they're in all ecosystems. There's at least one type, one species of bacteria. It may not be the same one in the different environments, but bacteria is abundant and it's common, right? Here's a close-up picture of a toothbrush bristle, right? So you brush your teeth, the little bristle, and we see all these plaques, these kind of little slimy looking things, right? Well, these are colonies of prokaryotic cells. These are colonies of bacteria, right? We brush our teeth to get rid of bacteria, but bacteria can actually grow on these toothbrush bristles as well, right? So they're everywhere. It's everywhere. It's part of our environment, right? The abundance, the ubiquitousness of these prokaryotic or bacterial cells. So if you remember a little bit about the prokaryotic cells, they are going to have that membrane that surrounds the cell. They don't have a nucleus. They just have this area all scattered throughout the cell, throughout the cytoplasm in which the DNA is found. And again, most of the bacteria are going to have the protection of a cell wall external to the membrane. And depends on the species, they could have other modifications external to the cell wall. They could have different structures for swimming, for moving. All that depends on the particular species, but we're just going to kind of look at the collective whole here. So when I talk about bacteria, I typically use the word cootie, right? Cootie is a game when we were kids we played. Cootie just sort of is a generic term for some sort of bug, for some sort of bacteria, a germ. So if I use the word cootie, you're not sure what that means, that's what I'm referring to, right? The cootie, right? So I don't know how you were raised, right? I don't know how many of you look like this at some point in your childhood. And if we look at this child all full of mud and dirty, we know this child has been playing in the soil and the dirt and probably covered with cooties, right? Covered with bacteria. Now, would you guess that this child is very sickly? Or would you guess this child is pretty healthy? So this is something that's going on in modern society, right? In modern society, we don't see children looking like this as often as they did in the past. And you think, well, maybe these kids, since they're not playing in the mud, they're being less exposed to bacteria, they're probably healthier. And in reality, it's backwards. That's not the case, right? So children that play a lot in the mud, they come into contact with bacteria, with cooties, tend to have a much better immune system, much better able to fight off, much lower incidence of allergies and that kind of stuff. So yeah, we were not meant to be as clean as we are, right? We were, think of wild animals. How many times do they bathe? How many times do gorillas and chimpanzees go take a shower, right? Not as much as humans. So again, our society, our cleanliness is having an impact on our immunity and our allergies. We are sort of supposed to have co-evolved and co-interact throughout our life with bacteria, right, to keep our immune system nice and strong. So bacteria ubiquitous in the mud, right? How about this scenario bottom left here, right? So how many of you are proponents of the 5-second rule, right? I don't know if you know what the 5-second rule is, but you drop your favorite food item, 1, 1,000, 2, 1,000, 3, 1,000. Oh, if you pick it up before 5 seconds, blow, get the little dust off, it's still good to eat. Yes, 5-second rule, right? So curious to know here if we're analyzing, how many of you would, 5-second rule, right? You drop the fries, oh man, you drop them. How many of you would eat this fry right here, far left? How many of you would eat that fry or this fry? I would suspect most of you said no, because it touched the ground, all right? How many of you would eat these 2 fries here, right? Most of you, I think, would say yes, it fell on the ground, but it didn't actually touch the ground. So here we're coming up with the idea and maybe a slight misconception that the ground must be full of bacteria, but the little cardboard, the little styrofoam is completely devoid of bacteria. And again, that is also a misconception. Now, probably there's going to be a lot of bacteria on the ground, but because bacteria was ubiquitous, there's probably some bacteria also on the styrofoam. Right? So it's not a sterile environment. It's not completely devoid of bacteria. So again, bacteria is ubiquitous. We come into contact with it more often than what you might think. And that leads me up here to the 10 o'clock news. I don't know how many of you watch the news. If you watch the news, you probably have this attitude at the end of the newscast that, man, the society is terrible. Our world is just going downhill. The news tends to report a lot of negativity, very, very few positive stories, in my opinion. Yeah, but When we're talking about bacteria, most of what you hear about bacteria is going to be sort of a negative idea, or the news emphasizing the harmful species of bacteria. So in reality, most bacteria is not harmful to humans. Most bacteria is either beneficial or maybe has no direct impact to humans. Again, 10 o'clock news, they're going to always report the sort of the dramatic aspects, the harmful, trying to hype up the negativity, that kind of stuff. So most people, if we were to interview maybe third graders, fifth graders, and we ask them about bacteria, they're going to tell us that most bacteria is bad and harmful. And to be fair, to be honest, yes, there are some species of bacteria that are pathogenic, that can cause disease, it can harm your system. But that number, the diversity of species that are pathogenic is actually much, much lower than the bacteria that are beneficial to humans. Right? So humans require bacteria for the production of vitamins. They require bacteria for the production of antibiotics, of vaccines. If you've ever seen a dead animal on the side of the road, that dead animal is decomposed, is broken down by bacteria. Right? So bacteria breaking down raw sewage, used to, for all kinds of sanitation of water, that kind of stuff. So if you live in El Paso and you drink tap water, your water is made crystal clear by the use of filtration, by the use of chlorination, different types of chemical treatment, and also by bacteria in the role of breaking down sort of components in that water. And if you say, well, I live in El Paso, but I don't drink tap water, I drink bottled water. Oh, well, look at the label of the bottled water and see where it came from. Right? Wherever it came from, wherever it was processed or packaged, the same process took place, right? So filtration, chlorination, chemical treatment, and bacterial treatment as well. So next time you drink that nice bottle or glass of clean water, thank these little beneficial bacteria for allowing us to have fresh drinking water like that, yeah? So again, I'm not gonna, we will talk about some pathogenic forms in a bit, but let me start off with a group, a genus of beneficial bacteria. We're gonna call these Streptomyces, right? Streptomyces is not to be confused with Streptococcus. Streptococcus, the bacteria that causes strep throat, yes, that's a harmful one, that's a bad one, right? Streptomyces is a good bacteria. It's a very beneficial bacteria for humans. It is going to be the producer of antibiotics, right? So if you put yourself in the scenario of a bacteria, so here we have a little bacteria, 1, 2, 3, who are reproducing, 4. So these bacterial species are in their environments. They're competing for nutrition, for space. And can you imagine some other bacteria or a fungus or some other organism trying to invade the space here, right? Well, if I'm a bacteria, I can't punch, I can't kick, I can't scratch, I can't defend myself very effectively. So what they do, they have evolved basically chemicals, these antibiotic chemicals that are secreted around them. And they basically toxify that area to where no other foreign invader can survive there, right? So Streptomyces can tolerate it, its offspring can tolerate it, maybe its neighbors can tolerate it, but other types of, different species of bacteria, different fungi would not be able to tolerate this chemical, right? So in essence, they toxify the environment around them and nothing else can grow except for them. So it's a nice way of establishing like a territory and basically allowing them to have space to grow, reproduce, and survive there. Right? So antibiotics. Just to give you a tiny list here, I could spend another hour talking about this, but We look at the different types of Streptomyces, right? Streptomyces venezuelae, Gricia, Streptomyces erythraeus. So all of these are Streptomyces and the different species. Streptomyces, 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 Streptomyces. So, and then these are common antibiotics that are available in pharmacies and utilized in medical situations. And we think, well, where did these chemicals come from? Were they manufactured artificially? Like, no, these chemicals naturally are produced by Streptomyces. So these little bacteria live out in the soil or minding their own business, trying to, make it each day, claim that little environment for themselves. And all humans have done, these pharmaceutical companies basically just come and steal all of these naturally produced chemicals, put them in a pill form, or they analyze the chemical structure and then they can synthetically reproduce them, right? But nature gave us this chemical first. So these very beneficial species of antibiotic producing bacteria. So again, I'm not going to ever ask you to memorize all this. Just again, some of the antibiotics you may have heard of, neomycin, nystatin, these are common. Some of these are quite powerful. Some maybe we don't use as much anymore, tetracycline. But again, all coming from a natural source from the Streptomyces bacteria. So again, we know bacteria can provide us with antibiotics. Bacteria then can help decompose dead organisms. Bacteria can also be utilized as a form of probiotics. And there's a slight distinction. So antibiotic is like a medication that you would take to fight off bacteria. Probiotics are actual bacteria that you ingest that are not harmful. But if you have a population of healthy bacteria, safe bacteria in our system, because of ecological situations like competition. So if I have a bunch of good bacteria living in my body, it's going to be difficult for the harmful bacteria to come in and start growing. Right? It's just a natural competition. We have both, or we have a lot of the good bacteria reproducing, taking up space, utilizing nutrition. So we said, who benefits in competition? Neither, right? By two bacteria species competing, it keeps the population low. Right? So probiotics are, again, something that would live in our intestinal tract, in our colon. And basically they can occur naturally, or you can actually consume, you can eat yogurt. We can sort of purposefully ingest these probiotic species there, right? So lactobacillus is one. There's a couple of others that we get, again, from our foods, and specifically from things like yogurt, or you can buy them in pill form as well. Yeah? So beneficial roles of bacteria. Now, I'm going to switch things up a little bit here, right? So these good bacteria and bad bacteria, the same, yeah, but they're going to have a very, very rapid reproductive rate. Right? So they reproduce fast. So we start talking about generation times. For humans, from the moment of birth to the time when that organism has their own offspring. Right? So from birth to the production of offspring. Right? For humans, that's anywhere from 15 to 20 years. Maybe some cases could be a little younger, some cases it's older, but on average, it's going to be somewhere between 15 and 20 years. So if we look at this picture here, right, multiple generations. So let's say we have, mom gave birth to child, gave birth to grandchild, great-grandchild, great-great-grandchild. Right? So if we look at this idea of 15 years, so 15, 30, 45, 60, about 75 years, right? So we're looking at about 75 years for 5 generations to be produced, right? So again, same sort of scenario. Now, in this situation, when we talk about bacteria, we're not talking about years now, right? Bacteria can start to replicate in about 20 minutes. So if you think of any mutation that can occur, how fast will it take over? You know, if, instead of 75 years, you're talking about a very very short amount of time. So 20 minutes, 40 minutes, 60 minutes, an hour and 20, and in an hour and 40 minutes, 5 generations of bacteria have happened rather than in 75 years, right? So in less than 2 hours, these things have reproduced about 5 times. And again, any mutation can very, very rapidly spread through the whole population. And all of our evolutionary factors, mutation, selection, flow, and drift all apply in a very, very rapid time frame there. I'm going to link this video if I can find it on YouTube, but it just kind of shows you an example of how rapid this thing can happen. So let's analyze this sort of example, right? So let's start off at noon. Right? So there's a sandwich that you make. I don't know, something happens, you're called away, you don't have time to sit and eat the sandwich. But because bacteria was ubiquitous, you have 2 bacteria present at noon. So that sandwich is just sitting out. In about 2 hours, we now have 128 bacteria. Wow, that's replicating fast. In about 4 hours, we go up to about 8,192 bacteria. And if you don't eat the sandwich and just sits there till 8 o'clock at night, now you're looking at over 33 million bacteria. So it just shows you how fast these things can replicate. So I don't know if any of y'all ever eat pizza for breakfast, right? Pizza that you bought at the party, it sat out for dinner, it sat out on the counter on the table, and you eat it for breakfast, not in the early morning because you don't wake up early, right? You wake up after lunch, and that's your breakfast maybe. Yeah, well, same kind of concept. That thing may be loaded with bacteria. So again, not necessarily mean you're going to get sick. It just gives us an insight on how ubiquitous they are, how fast their generation times can be. And if you do happen to get some sort of food poisoning, it's not necessarily because of the single bacteria, it's because of the massive number of individual bacteria that you're consuming. So just be aware. I don't know if you're fans of like hot dogs at Circle K, that kind of stuff. I always wonder, how long are they sitting there, right? In this warm environment in which bacteria replicate even faster. Sushi, I don't know if you're fans of sushi, right? Good stuff, but if you think about, El Paso, where's our nearest body of water, right? So when you talk about fresh sushi in El Paso, makes you wonder, wow, fresh sushi, where are they catching this from? Yeah? So be aware, if you eat sushi, know where it's coming from. You hope that it has been kept refrigerated or cold, or been processed, not left out for any lengthy period of time, because again, it can harbor a lot of bacteria. Organic foods, a lot of people that shift into organic foods initially suffer from stomach discomfort and things like that, because if you think about organic, right, well, what kind of fertilizer is utilized to fertilize organic foods? It's got to be natural, right? Which is typically some sort of manure product. So a lot of people are used to the chemicals and pesticides and herbicides that are used in commercial food production, right? And then when they shift over to this natural fertilizer, different types of bacteria, it takes them a little while to get accustomed to that. I found this on the web. I thought that was interesting, right? Tacos el churro, with a cow holding some sort of margarita or some sort of cocktail dish with a bikini, right? I thought that was interesting, right? But if you've ever eaten at these little puestecitos late at night, these little food stands late at night, you wonder, man, do these people have their food handler's card? Are they using proper sanitary, food handling techniques and food storage techniques? I don't know, right? I know it's delicious, but I don't know how safe it is, right? And a lot of people may end up with some stomach aches or some other types of issues with these types of foods. So again, just be smart, be aware, use common sense, and just know what kind of food you're consuming, and know how the ubiquitousness and rapid generation time of bacteria can be a factor. I don't know if you're fans of all-you-can-eat buffets, right? All-you-can-eat buffets are, interesting environments for bacteria. Right? One, it's warm. Two, there's a lot of sort of movement, different people moving through here. If there's kids around, kids they take something, no, they don't like that one, they put it back, whatever, right? So just be aware. You want to go to an all-you-can-eat buffet, that the food is moving, right? So you want it to not be sitting there for hours and hours and hours. So if it's been there, they eat it and they keep bringing out fresh batches of that food, right? It's a little bit of a better, a safer type of eating establishment there. So when we're talking about bacteria, let me introduce now the first species of bacteria that some of you may be aware of. I don't know if you've heard of Salmonella. Right? Salmonella is it's a common bacteria. Can be potentially pathogenic. May or may not be. Again, it depends on how much you're exposed to. Right? So Salmonella is associated with sort of moist environments, can be associated with poultry, uncooked poultry, eggs, and reptiles get a bad reputation for harboring Salmonella. It is true they can have Salmonella, but it's also true that depending on how the turtles, particularly turtles, are kept, has a big impact on the Salmonella risk, right? So first, right, let's look at issue number one. If pet shop owners are following the rules and regulations, they are not going to be selling these baby turtles, right? Baby turtles are small, they're cute, they sell fast because they're so cute looking. But understand, kids, little small children can pick up these little turtles. The turtles are not strong enough to fight off the little kid. And if you know something about kids, they always put things in their mouth. So if you have a contaminated turtle and the child puts it in the mouth, the turtle's trying to escape, the turtle's covered in this contaminated water maybe, and when they get scared, turtles poop. So what's one easy way to get Salmonella is let a turtle poop in your mouth. Yeah? That doesn't sound fun, but that's sort of the issue. So pet shop owners should not sell baby turtles that are small. Right? They should have a certain sort of size, shell length, shell width sort of measurements that make them safer. That a small child will not be able to handle them. So also, if children are handling turtles, depends on what environment they're in. In a natural setting, the turtle would be out in the lake, out in the river, in the pond, right? So the turtle poops and that poop sort of drains away. In a captive environment, these turtles are going to poop in the same water that they're living in. And depending on how good the filters are or how often the pet owner cleans the environment, could lead to greater incidences of Salmonella in that tank. And if children are handling the turtles and then don't wash their hands, they can ingest the Salmonella as well. So again, be smart, use common sense when working with different species of animals as well. Talking about Salmonella, I don't know if you were ever fans of Rocky. As a kid, Rocky was like my hero. Man, Rocky Balboa, he beats up people. He can defend himself pretty well. Being small and scrawny and dealing with bullies growing up, we wanted to be like Rocky, right? And me and some of my buddies growing up saw that Rocky for breakfast, he would eat eggs, but not like scrambled like this. No. He would crack them raw and drink them raw and then go train, right? So we thought, man, now that's the first step. Nutrition must be important if we want to be like Rocky. So we crack these eggs. We drink them raw. I remember nasty, like gagging, and but I want to be like Rocky, right? So we ate a couple of them, and we looked at each other, and we in school, in class, and then maybe few hours later, we start to kind of not feel so great. And this was us later in the day. And instead of being like Rocky, we ended up being sick for the next couple of days, just, you know, losing weight, feeling weaker, throwing up all day. And it was not a pleasant experience. So I felt a little bit disappointed. Rocky Balboa kind of let me down, I felt. But now I know what happened, right? I'm not going to blame Rocky. I'm going to blame the undercooked, or I should say not cooked, eggs that we ingested. So be aware, be smart, and again, understand the possible risk, possible role of these bacterial species. So for this next bit, I'm going to pause this discussion here, and then I'm going to continue with our second presentation on bacterial taxonomy. So let me stop that right there.